Hey everybody, this is a solutions video to elementary stats test over chapters 4, 5, and 6, the spring of 2012. This is mostly on probability and then a little bit on the normal distribution. The first questions here on normal or just on probability is just, I think a lot of people maybe read too much into this. It's just probability success over total. So there's three answers to a question. What's the probability you guess it right? So that's 1 out of 3. Probably you guess it wrong, 2 out of 3. And then what's the probability of getting 2 right in a row? So they're independent events. So it's just 1 out of 3 and, which is multiply 1 out of 3. So it's 1/9 or about 0.1 repeating. 3 wrong in a row would be 2/3 and 2/3 and 2/3. So multiplying 2/3 3 times, which can be written this way, which is about 8/27, which is about 30% chance of getting 3 wrong in a row. 5 right in a row would be 1/3 times 1/3. So a quick way to write that 5 times is 1/3 of the 5th, which can also be written as this fraction 1/243, and there's the decimal approximation. What's probably getting exactly 3 out of 6? This is a binomial because there's different ways to get 3 out of 6. So this 6C3 takes care of all the different ways you could get 3 out of 6 right. And here's the probability of getting 3 out of 6 right. So 1/3 of the 3rd, 3 right, 2/3 of 3, 3 wrong, and then times all the different ways it could happen gives us about a 22% chance of getting 3 out of 6 right. And then what's at least 5 out of 6? So the ones that would satisfy with that would be 5 or 6. I know it's a little tricky when you see the word at least there. That's a little tricky. I taught you it's 1 minus the opposite, but this isn't really asking that. So took a little thinking that you need to find the probability of getting 5 or 6 correct, which is the same thing as what we did up here. But here's 5 and 6, and you add those together and you get about 1.78% chance. On number 2, is it weird that a bus would be arrive on late? Well, you find the probability that's late is about 0.046. It's less than 5%, so we're going to say that is unusual to be late. Number 3, probability that it's a man, so you just took men, 545 out of 1124. Women is 579 out of 1124. Man or, and this is a typo, it's supposed to be not a heavy non-smoker, because otherwise I'd be inferring to non-smokers as being heavy. So that's a typo, but I think everybody figured out it's just non-smoker. So here's man, here's non-smoker, and here's how many that are both. So it's probability of A, probability of B minus the intersection, because these all got counted twice. So there it is, 964 out of 1124, about 86% chance. Regular smoker given they're a woman, so how many are regular smokers? And we're only looking in the women category. So 89 out of women is 579, and the other one is probably the woman given regular. So regular on that one becomes our population, so that's why it's 89 over 172 on that one. On number 4, we want to get 2 good ones in a row. So what's probably of it being good? Well, there's 32 bad and 8 defective, so it's 32 out of 40. That's the probability that it's good, and we want it to happen twice in a row with replacement. So you just multiply those again, and it's really 0.8 times 0.8, which is 0.64. Without replacement, only changes it a little. The first one is the same. The second one is 1 less. There's 1 less good, and there's 1 less total. So very, almost the same probability, but just slightly lower. Odds of success over failure. So it's 32 good, 8 bad. There's the ratio. Odds of picking 1 defective. So now defective, there's 8 defective and 32 that are not. So that's what that one looks like. On 5, expected value. So here's the formula that they give you, and when you roll a fair die, here's the probability times what you, so there's the probability times what you get when it happens. So there's 1/6 times 1 plus 1/6 times 2 all the way through the roll of the dice. The average is 3.5, and I think we did that one in class too. 6, by a $1 lottery ticket, they're giving away one $500 prize. So you can think of it this way: they're going to take in $1,000 and pay out $500. For the people playing, that's a net of loss of 50 cents per play. You could use the expected value formula on that too. You've got essentially for sure you're going to lose $1, and you have the probability of winning is 1 out of 1,000 times 500, which is about 500. So there it is. So or 0.5, I mean. So there's a negative 0.5. And then bullseye 7 out of 10 times. So there's 10C, or they get exactly 4 times. 10C4, probability of success is 0.7 to the 4th. And the probability of failure is 0.3, so you take that to the 6th. These are straightforward. You just need to look up 1.13 in your z-table, and there you go, 0.8708. Again, look this up in your z-table, 0.59, and then take 1 minus that. Area to the right is 0.2776. And the area between would just be, look up 1.56, which is 0.9406. Look up negative 1.56, which is 0.0594, and find the difference to find the area between. So it's this total area minus this little area gives you what's between. In 11 here, we find the z-score for a 625, and that's a 1.47. And then what's probably being greater than that, so there to the right is 1 minus, and you look that 1.47 up in your z-table, and you get 0.9292. So there's the probability that's greater than 0.0708. And then what's the mean? So that's the central limit theorem, mean of a group. So now the only difference is we divide by the square root of 16. And this is a very rare event, almost 6 standard deviations away from normal. And if you find that probability, if we draw that picture, let me see if I draw that picture. So here's the, oh, hit undo there, sorry. There it is, the picture's already there. So then you draw that picture, that makes that even farther out. And if you look that up in your z-table, it's not even on your z-table, which means it's almost impossible, or nearly 0 for the probability. On 12, they want you to use the z-score to find the top 4%. So if you look up the top 4% in your z-table, you get 1.75. So if you're 1.75 standard deviations above the mean, that's the top 4%. And then we set this up and solve for x. So we multiply both sides by the standard deviation and then add the mean. And there it is. So somebody with a temperature of 99.3 is in the top 4%. And then the bottom 10%, that's negative 1.28. If you look that up in your z-table for the bottom 10%, again, multiply with the standard deviation, add the mean, and we get 24.36 would be the score. And obviously it should be below average if it's the bottom 10%. 14, we found the z-score for this first exam. They scored at 18, the average is 25, and there's the standard deviation. So they were 1.42 standard deviations below the mean. Question is what's the equivalent on the other exam. So we use this z-score here, and it's almost like the last problem where we solve for x. So we multiply both sides by the standard deviation, add the mean. So the equivalent on this exam would be a 53.95. And 15, what's the probability that they're above is 7.1. So again, find the z-score, you get negative 0.46. Look that up in your z-table, you get the 0.33228. But we want the area to the right, so you take 1 minus that, and which is about 67%, 68%. And then the last one is divide by the square root of 25, because you're looking for a group mean of mechanics, and that's a much farther away z-score. If you look up negative 2.32 in your z-table, you get 0.0102. Again, we're looking for the area to the right, just like up in here. So that's how we get 0.9898. There was 40 points possible on this test, and I did not have to curve it all since there was several A's even and some perfects. So hope this helps you get ready for the final or the exam for the new semester.